Hello, let's continue our Sudoku adventure with Peak Excitement by Calvinball. So, given that today is Thanksgiving, at least here in the US, I thought I would pick a food-related puzzle that was in the queue, and Calvinball has this one that is split pea related. So we're having split pea soup today in honor of Thanksgiving. So, let's go over the rules. We do have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these thick green lines in the grid. These are German whisper lines. That means that any two adjacent digits along the line have to have a difference of at least 3. So if this was a 2, this could be a 5, because 5 minus 2 is 3. That is at least 3. Or this could be a 6, because 6 minus 2 is also at least 3. It's 4. So we could do, say, maybe 5, 2, 6 if this was a 2. What we can't do is like 2, 4, because 4 minus 2 is 2. That is not at least 3. Or 2, 3 is 3 minus 2 is 1. That's not at least 3. All right. And in addition to that, we do have these circles that have these thin green lines connecting them. These are split pea lines. Just assume that the lines continue along the path of the thick green one. They are not German whispers, though. So these two cells that are separated by just a thin green line, they are allowed to have a difference of less than 3. They do not follow the German whisper rules, but these two do, and these two do, but these two do not. But what the rule they do follow is whatever two digits end up here. Let's follow the example. Say we have a 3 here, 1 here, and a 3 here. Then we would read that as 13 or 31. We don't know which, but it's 13 or 31. And then the cells that connect them along the line would then sum to 13 or 31. So in the case of 13, we could do, say, 3, 4, 6. So 3 plus 4 plus 6 is 13. That matches this being 13. Now, this does break our German whisper line, though, because you can't put a 3 next to a 4. You can't put a 4 next to a 6. So that isn't a possible solution with that German whisper line taken into account. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, how should we get started? Well, we know the sum of this line. It's 21 because it's just in an entire box. It's all the cells in the box. All the cells in the box are 1 to 6. 1 to 6 has to 21. So this is a 1-2 pair. And I'm going to color that blue because it's low. Okay, I'm going to color this blue and orange. I use blue for low and orange for high. Now, why am I doing low-high? It's because of the German whisper behavior. So let's say this cell here was a 1, 2, or 3. We call that low. 1, 2, and 3 is low. 4, 5, 6 is high. Now, if this is low, then we have to move to a high digit next to it. Because another low digit couldn't possibly have a difference of at least 3. It's just not going to happen. Best we can do is 3 minus 1 is 2. So we have to jump to 4, 5, 6. Once we're in 4, 5, 6, we have to jump back down to 1, 2, 3. So it alternates. So if this was 4, 5, 6, we'd still alternate, right? Back down to 1, 2, 3. So we don't know what it is, but we do know that it alternates. And so by coloring these lows and highs, we might be able to figure out how that alternation happens. The 4 looks up, putting a 4 on one of these two. It's a 4 somewhere over here. Should I think about this line maybe? So the first thing I'm thinking about is, can it be on the low end? The low end would be 2 blues and an orange. So 2 lows and a high. Now, so this could do 3, 6, 3, which would add to 12, which would put, yeah, I was going to say put a 1, 2 pair here, but we have this 1 conveniently looking at here. So it would be a 1 here with a 2 here. So is there some reason that wouldn't work? Actually, yes. This is a bit of a look ahead, but the 2 3s looking down would put a 3 in one of these two. Now, which of these could actually be a 3? Well, this one couldn't be, because it would force a 6 to be here. 3 is a little bit special in that there's only one digit that's 3 away from it, which is the 6. At least 3 away from it, I should say. You can't subtract 3 or more. That would get you into the 0 range. And if you add 3 or more, you end up in 6 or higher. So, but that would double up to 6. And if the 3 were here, this is another issue, which is it only has the 6 that can be next to it. So it would double up to 6 next to it, which is no good. So for that reason, we actually can't be low, high, low. Because 12 is the absolute minimum we could add to, right? This could be a 1, and this is minimum 2, and that's 12 minimum. You can't get smaller than that. So as a result, it's actually the opposite. This is high, low, and high. I don't know what to do with that yet. So let's just write out 1, 2, 3, and 4, 5, 6 here. Now, what does that mean here? So what is the biggest this could be, I guess, is another good question. Well, we could do 6, 3, 6, which is 12 plus 3 is 15. So if the biggest we can get is 15, then we need a 1 in one of these two to represent the tens digit, and this can't be the 1. So this is 1 and this is 2. A 2's up here somewhere. I could have put that earlier. And so this is 2, 3, 4, 5, because our max was 15. Okay. Now, I'm thinking about this 4 here. If this was 4, this would have to be 1, because only 1 can go next to 4. That adds to 5. The max here would be 6. 5 plus 6 is 11. We can't make this 11. So this can't be a 4. I think this does the same thing. 4 puts a 1 here. That would be 5. Plus max 6 would be 11. So this is also not a 4. So we can get rid of this corner mark 4 here. All right. I don't know that we can do more with this line, though. Like, this could be 3 double 6, and I don't really see a reason it shouldn't be. Okay, so let's think about this a little bit more. What else can we think about? Is it this line here? Should we think about where 4 goes in this box? Because it's not here. Oh, it's not over here. Okay, so even in a void, where could the 4, where do the 3 and the 4 go on this line? I guess is kind of the first question I want to ask. Could always go at the ends of the line. Except this can't be a 4 because, not because of this line here, but because 4 would force a 1 here. Because of this German whisper line, and that would double up the 1 in the column. So that can't actually be a 4. But so I'm just marking where, why don't I corner mark where 3s and 4s can go, because that's kind of what that means. Here it can't because it would double up. Here it can't, it would double up. Here it can't, it would double up. And here it can't, it would double up, right? So it has to be on the ends. And so this is our 3 and this is our 4. That places the 4 in here. 4s are high, 3s are low. 3 can only be next to 6, that's high. In fact, we can just do low, high, low. 4 has to be next to 1. And then what's left is the 5 and the 2. In fact, this is something I've seen across a whole row. I've seen that logic. I should have realized the same thing happens within a box, but it didn't really click for me. That you always end up with this 4, 1, 5, 2, 6, 3. You end up with that ordering when a German whisper line fully encompasses a row, column, or box. That does make this a 1, which is quite limiting. So the biggest this can be is 13. 6 plus 6 plus 1. So this can't be a 4. So it is low. So we need a 4 over here somewhere. If this was 4, this would be 1. That doesn't work because there's already 1 there. So this is our 4. It's high. This is the 2, 3. And so now we can do high, low, high, low, high, low. This sees 4 and 6. So this is 5. This sees 1 and 3. So it's a 2. Take a step back here. This is 5 in this box, because these two 5s looking up. Here we need a 3 and a 6, and so that means this is the 1, and it's low. So we know that this is 2 lows and a high, so this is 2 lows and a high, and then this is low. And we know the 2 lows are a 1, 2 pair. This 1 tells us that's 2, that's 1. Gives us the 3 and the 2 here. And then these are... Oh, this is a 3. Oh, this is a 2. 3 in this box can only go here. And this is high. Okay, so this is the 4, 5 pair. This is the 6. 4 definitely doesn't go here. It's next to 2 2s. So that's 5, that's 4. Places the 4 here. This column finishes with a 3. That gives us high, low, high, high. Okay, so this is 6, 3. 3 has to be... Oh, no, that 3 does not have to be next to 6 here. On a German whisper line. Let's do this. This is 6. Interesting. Maybe we need to do the split P here. So, okay, we add to 13. So we actually have to be the 6, 6 here and then the 5, 5 there. I was like, what's going to resolve that? Okay, cool. That was a neat puzzle, Calvin Ball. I enjoyed that. I think thinking about, I had to remember how Durham Whisper is within the same house, row, column, or box, behaves when it encompasses all 6 cells. And I could have done that much earlier, but didn't consider it till later. All right, cool. Well, let me know how you did. And if you enjoyed this, why don't leave a like, subscribe, and a kind comment below.